Hello children. Today we are going to study about variable valency. Before going to variable valency, we'll just brush up that in last video we had seen metals, they lose electrons to form the stable electronic configuration, and non-metals accept electrons to achieve stable electronic configuration, and the number of electrons they donate, metals donate, and the number of electrons non-metals accept, those number of electrons are known as valency. So if magnesium donates 2 electrons to achieve the stable electronic configuration, then the valency of magnesium is 2 and it is known as divalent. And if lithium donates 1 electron to achieve the stable electronic configuration, then the lithium is known as univalent. Similarly, oxygen, as it accepts 2 electrons, it is known as divalent, and chlorine accepts 1 electron, so it is known as univalent. Nitrogen, as it accepts 3 electrons to achieve the stable electronic configuration, it is known as trivalent, and so on. Now we understand what is variable valency. Now when we are trying to understand what is variable valency, let us look into the definition of the variable valency. So elements that exhibit more than one valency is known as variable valency, means they show variable valency. So in this case you can see I have taken an example of copper. Before going to that, I would like to show you the periodic table. This is the periodic table. Now in the periodic table you can see the elements which are placed over here at the center of the periodic table, middle of the periodic table. These particular metals are known as transition metals. So these metals, they exhibit more than one valency and they all have variable valency. So we'll understand with respect to copper that what is variable valency. So here you can see that copper, if it is having +1 state, it will form cuprous chloride. Then the molecular formula of cuprous chloride with chlorine will be CuCl. If it is having the valency 2, then it will form cupric chloride and the molecular formula will be CuCl2. That means it is forming two different compounds, and that's the reason it is showing variable valency. That is, when it is trying to combine with the same element or the non-metal, that is chlorine, it is here going to form CuCl, but here it's going to form CuCl2. So how this is possible? Now here it's written that the reason for copper showing variable valency is that is it loses more electrons than which is present in the valence shell. In the last video we have seen that whenever we want to study about valency, we have to concentrate on its valence shell, and it will always lose electrons or gain electrons with respect to the number of electrons present in the valence shell. But here in these elements which show more than one valency, you have to focus on the valence shell as well as on the penultimate shells. Penultimate shell means the shell before the valence shell. Now this last shell is known as valence shell. Penultimate shell is one shell before the valence shell, and what happens is, here you can see that in case of copper, the electronic configuration of copper, as the atomic number of copper is 29, it's written 2, 8, 18 and 1. This is K shell, which has the capacity of 2 electrons. L shell has the capacity of 8 electrons. M shell has the capacity of 18 electrons, and N shell, the one extra which is there, which is left, that is filled in the N shell. So this one electron, when it is losing from the valence shell, then the valency of copper in that case is 1. But sometimes what happens, this penultimate shell, there are certain electrons which are in the excited state, and the electrons jump from the penultimate shell to the last shell, that is the valence shell, when they are in the excited state. So when this one electron from the penultimate shell jumps from the penultimate shell to the valence shell, then the number of electrons becomes 2, and in that case the copper will lose 2 electrons, and then it will have valency 2. So that is how, in case of transition elements, we say that the last 2 orbits are incompletely filled. That means the electrons, when they are in the excited state, they jump from this electron, the penultimate shell, to the last shell. So because of this, the valency keeps on changing. Sometimes copper shows valency 1 and sometimes it shows valency 2. Now this was all about the variable valency. Now we'll understand what is the meaning of radical. Now radical means there are 2 types of radical, positive radical and negative radical. Now here in case of ion, before, like in the last video, we have seen that whenever you are talking with respect to ion, it is with respect to one metal or one non-metal. But when you are saying, or when you are using the word radical, it means there are more than one element in that unit or in that group. So you can see here I have written ammonium. So ammonium is a radical, and in this case you can see that along with nitrogen there is hydrogen also present. So there is group of elements which is present and they combine to behave like a single unit. And when they are trying to behave like a single unit, you can see here nitrogen, the electronic configuration of nitrogen is 2, 5. So it has 5 electrons in the last shell. So 5 electrons means it is having, you can see here I have shown it with the dot structure. This is electron dot structure. So dot is for the number of electrons that nitrogen possesses. So here you can see 1, 2, 3, 4 and 5. Now this hydrogen, it's combining, or you can say it is sharing these electrons with the nitrogen. So it's a covalent compound. Covalent means the sharing of electron is taking place. So here you can see these electrons are shared between nitrogen and hydrogen. These 2 electrons are shared between nitrogen and hydrogen. These 2 electrons are shared between nitrogen and hydrogen. That is how nitrogen, you can see how many electrons it has now, 1, 2, 3, 4, 5, 6, 7, 8. That means it has stable electronic configuration. Now this particular hydrogen, as you can see, this particular electrons, they are not shared by any of these elements. It is present, and this particular pair of electron is known as lone pair of electrons. So this lone pair of electron which is present over here, this hydrogen, it comes and it combines. It combines means it is not going to give any electron. It is not going to contribute from its side any electron, but it is going to come and attach over here, and that's the reason this particular ammonium ion gains positive charge. So this ammonium ion, as it is a group of elements behaving like a single unit, this particular ammonium ion is known as positive radical due to positive charge which is present on it. And here you can see it is hydroxide. Hydroxide consists of oxygen and hydrogen, where you can see the valence electron of oxygen is 2, 4 and 6. Okay. Oxygen electronic configuration is 2, 6. So outermost shell has 6 electrons. One of the electron is shared with hydrogen. And here, because of that, you can see that it gains negative charge. Because here hydrogen is going to contribute 1 electron. And due to that, the negative charge is developed on the hydroxide group. And that's the reason, as it is a group of elements which behave like a single unit and it has negative charge. That's the reason it is known as negative radical. Is it clear? Thank you.